This question has to do with the general wave equation. Here's the question. A wave is represented by the equation y is equals to 0.2 sine bracket 0.4 pi bracket x minus 60t brackets and the bracket again, where x and y are in centimeter and t is in second. We have to look for the velocity of the wave. The wave equation is given to us, which is y is equal to 0.20 sine 0.4 pi bracket x minus 60 t, and we have a bracket there again. We'll have to open this the bracket to make it more unique. 0.20 sine 0.4 pi times x will give us 0.4 pi x minus 0.4 pi times 60 t will give us 24 pi t. Let's call this equation 1. Then the general form of the equation is given as y is equals to a sine bracket kx minus 2 pi ft. Call this equation 2. If we compare equation 1 and 2 together in terms of the terms in each of the equation, we discover that 2 pi ft will be equal to 24 pi t. That means this term is equal to this term. That's what I refer to. Making the frequency f the subject of formula, we end up having 24 pi t all over 2 pi t. T get rid of t, pi get rid of pi, and we are left with 24 all over 2. 24 divided by 2 will give us the frequency of 12 Hz. Now that we have the frequency, we can also solve for the wavelength. Comparing kx with this other term, 0.4 pi t, we can have kx is equal to 0.4 pi t, 0.4 pi t. I'm making k the subject of formula here. That will give us 0.4 pi x all over x, and the x get rid of x here. We have k 0.4 pi. But generally k is expressed as 2 pi all over wavelength. That's a expression for 2 pi all over wavelength. If we work with that, we compare both sides. That means that 2 pi all over wavelength is equal to 0.4 pi. Making the wavelength the subject formula here, we have 2 pi over 0.4. 2 pi all over 0.4. 0.4 pi. Pi get rid of pi. We end up having divide everything and give us 5 meters. 5 cm, please. Cm. Now the wave equation, let's say V is equals to frequency times wavelength. We calculated the frequency to be 12 and multiply with the wavelength there, that is 5 cm. That gives us a speed of 60 cm per second. So the speed of the wave in the question is 60 cm per second.